Conditions. Hopefully you followed all the steps in the previous video and have VS Code installed and you cloned the repository for the course. If you haven't, then jump back and follow the steps to be ready to code along with this lesson. If you open VS Code and open the workspace for this course and select the Explorer button, the top one on the left, you should see a file layout like this. Notice the resources includes a complete and a start folder. For every example in the course, the code along version is in the start folder, and if you get stuck, there's a complete version in the complete folder. To work along with this video, I want you to open the file index.html in the folder Start Lesson 4. This is a very simple HTML page. I'm assuming you have some familiarity with HTML. An HTML page has a series of tags inside less than and greater than brackets and ends with the same name inside the same style of brackets, only including a /. Tags can be nested inside other tags. Here we have HTML as the outer tags. Inside the HTML tag is a head tag and a body tag. VS Code allows you to expand a tag, something that can be very useful as the code becomes more complex. Before we enter any code, I'd like to show you how to view the pages. As we saw in the previous chapter, you should have the live server extension installed. If you haven't done this step, go back to the previous video and complete it. Find index.html at the root of the resources, right-click and choose Open with Live Server. In the browser you should be looking at the default index.html page. For this lesson, select Lesson 4, Start. You'll be totally unimpressed, since all you'll see is a white screen. Bear with me here, it will get better. Rome wasn't built in a day, as they say. Now, open the developer console. Remember the keyboard shortcut? F12 to open Developer Tools, then select the Console tab. Now we're ready to enter some code. Over in VS Code between body and the body close tag, add a script tag. VS Code will automatically add the closing tag. Later in the course we'll use separate files for the JavaScript, but in this lesson we're going to add our code to the index.html page. For this the code must be in a script block. We're going to enter a new function. We'll call it compare, and it has two parameters, A and B. Now the condition. This video is called Conditions, and this is our first. We use the keyword if, followed by brackets. What we enter inside the brackets must evaluate to a boolean. Hold on, evaluate, boolean, what does that mean? It means whatever we enter inside the brackets has to be either true or false. As an example, enter A is less than B. Angle brackets left is the less than operator. Following the closing bracket, we enter curly braces. Strictly speaking, if we only have a single line following the brackets, then we don't need curly braces, but I highly recommend you always use them. Inside the curly braces, enter console.log A is less than B. The complete code should now look like this. Remember to save your work, then back in Chrome, let Live Server refresh the page, and in the console panel enter compare 1020. If you enter the code correctly, you should get the response A is less than B. In the console, what just happened? You wrote your first real JavaScript code. When you entered compare 1020, A is 10 and B is 20. The program reaches this line, if A is less than B. It reads this as if 10 is less than 20. 10 is less than 20, so the statement inside the brackets is true. So the program moves to inside the curly braces. This prints the line A is less than B in the console. Fine, But what if we enter compare 2010? Now A is greater than B, and so we don't get a response in the console. We just get undefined because this function does not return a value. When we have an if condition, we can add a block of code that happens when the condition is false. To do that, we use the keyword else, then curly braces, and this time in the curly braces enter console.log A is greater than B. The complete code now looks like this. Save the file, let live server refresh the browser, and enter compare 2010. Again, this time you see A is greater than B. But what if we enter compare 1010? Again we get A is greater than B. But A equals B. Why do we see the message A is greater than B? Because A is not less than B. And so the condition A is less than B in the brackets evaluates to false, and execution jumps to the else block. We can fix this. As well as if and else blocks, we can add an else if block, like this. Before the else, add an else if. Notice the space between the words else and if. Now we can enter a new condition between the brackets and a new code block between curly braces. In the condition enter A double equals B. The complete code is now this. Notice in the new condition we have two equal signs. This is not a mistake. In JavaScript and many other programming languages, two equal signs means we're testing for equality, whereas a single equal sign means we're assigning a value to the variable on the left of the equal sign. Despite looking similar, they're not the same at all, and this is a common cause of bugs in code, mistakenly using a single equals when double equals was required. If you save your work and go back and refresh the browser, now when you enter compare 1010, you'll get the response A equals B. What if we try to use a value that isn't a number? JavaScript will try to convert the value to a number. Compare 10 in quotes 10 will be fine, but for this you'll get A is greater than B, not because A is greater than B, simply because A is not a number, so the JavaScript processor cannot evaluate A is less than B or A double equals B, and so these conditions are evaluated as false. At the start, add a new condition. If is nan A. Console.log A is not a number. Is nan is a built-in JavaScript function that tests if a value is not a number. For a string that can be converted to a number, the function will return false, but if it cannot be converted, the function returns true. The compare function now looks like this. You know the form, save, let live server refresh the browser, then enter this code. Now we get A is not a number, but we can still get an erroneous message if B is not a number. Can you fix this? You'll need to add a new else if condition and code block. Pause the video and give it a try. You add else if is nan B. Console.log B is not a number, giving the complete function as this. Save, refresh and enter this code. Now we get B is not a number. Now we have 4 conditions and a catch-all else. That's about the limit for using if. There's another way of choosing a variety of options though, and that's to use switch. After the closing curly brace of the compare function, enter function today const day equals new date dot get day. Here we create a date object. We need to use the new keyword to create an instance of the date object. If you create a date object using no parameters, notice the empty brackets, then it will be initialized to the current date and time. A date object has several methods, and here we use the getDay method. This returns a number between 0 and 6. 0 means today is Sunday, 1 Monday, all the way up to 6 meaning the day is Saturday. Now we have a numeric value. We can use it to display a message indicating the day in English. We start with the keyword switch and then in brackets add the value we're using for the switch. Then we add case blocks. Case 0 followed by a colon, then one or more lines of code. Here we just have a console log message. A case block ends with break, and when the processor reaches break, it jumps out of the switch statement. Can you add the remaining 6 case blocks? Pause the video and give it a try. Hopefully that wasn't too hard. We're adding case 1, case 2, case 3, case 4, case 5, case 6. Now save, refresh the browser and enter today. You'll get the response today is with whatever day it currently is. Try to use a switch statement when an if-else-if block has more than 3 or 4 conditions. It isn't always possible. It all depends on the problem. There's one other use of conditions that I'd like to point out, and that is the conditional operator. This is a shortcut version of an if-else statement. It's used when we're assigning a value, and it can take 1 or 2 different results based on a condition. An example will make it clear. Let's create a function that will return a string saying if today is a weekend day or not. We'll get the day index as before using the date object and the method getDay. Looking at the today function, we can see that a weekend day means a day is either 0 or 6. We enter return followed by brackets containing a more complex condition than we've met so far. Here we have 2 conditions joined by vertical lines. The 2 vertical lines means logical OR. Here we join day equals 0 and day equals 6 with an OR operation. That means if either day equals 0 or day equals 6 is true, then the whole condition is true. Here's a table showing how it works with these 2 inputs. The column to the left shows the possible values for day equals 0 and the top row the possible values for day equals 6. Notice if day equals 0 is true, row 2, and day equals 6 is false, column 3, then the result is true. Only row 3, column 3 gives a false value when both day equals 0 and day equals 6 are both false. We'll meet more logical operators as the course progresses. Now we enter a question mark. The first thing after the question mark will be the return value if the condition is true. If day is equal to 0 or 6, then we enter a colon and finally the return value if the condition is false. Day does not equal 0 or 6. Save, refresh the browser and enter weekend. The return string you get depends on the day you're watching this video. Conditions are widely used in programming to control the flow of the program. So now you know about variables, functions and conditions. And next up are arrays, a special kind of variable that can be very useful. See you in a minute.